Here's another example problem from Chapter 8. And this one, we've been given the initial V0 and I0, and then the final V infinity, I infinity. Also alpha and omega naught, so it makes it a little bit easier, but we still have some work to do. So first, let's look at what category we're in here. We have alpha greater than omega naught. That means we're overdamped. If we're overdamped, this book is in my way, move book, then our general solution is V of t equal V infinity plus A1 e to the S1t plus A2 e to the S2t. I guess I didn't ask what we were, didn't put what we were asked to find. We were asked to find V of t. So we were asked to find I of t. We want to use I and go from there. But they asked for V, so there you go. Okay, what else do we need? So for this one, we need S1 and S2. It's minus alpha plus or minus the square root alpha squared minus omega naught squared. And if we do that, we get S1 of minus 0.167 and an S2 of minus 47.83. So obviously I just did that with a calculator. So now our V of t is equal to our final V, which was 30, plus A1 e to the minus 0.167t, plus A2 e to the minus 47.83t. We can go ahead and use our initial condition of V of 0. V of 0 was given as 24. So we're going to plug that into here. We get 30 plus A1 e to the 0 plus A2 e to the 0, or A1 plus A2 equals minus 6. So there's our first equation. And now we need to do the derivative. So let's find dv of t by dt. We get minus 0.167 a1 e to the minus 0.167t minus 47.83 a2 e to the minus 47.83t. It's all smushing together a little bit there. We need that initial condition. We know dv by dt is equal to I over C, the current through our capacitor. Do we know that? We do, because our capacitor and inductor are in series. Since they're in series, and we were given this, we know that current through that inductor, through that capacitor as well. So it's 0.5 over C, which is 0.5, or 1. So I know that dv of 0 by dt is equal to 1, plug 0 into here, equals minus 0.167 a1 e to the 0 minus 47.83 e to the 0. So now I have two equations and two unknowns. I have this equation, and I have this equation. So, solve that for A1 and plug it in, whichever way you want to do it. But when you do that, you get an A1 of minus 6, an A2 of 4.196 times 10 to the minus 5th. So kind of a weird number, but it is what it is. So our final answer is 30 minus, we're plugging A1 and A2 into here, minus 6e minus 0.167t plus 4.196 times 10 to the 5th e to the minus 47.83t volts. Well, there is our final answer.